Hello, in this video we are going to look at network. Network is the sum of the work done by all the forces acting on the objects. So if we have to take these objects into consideration, now a force of 30 Newton is applied to these objects at an angle of 20 degrees through a displacement of 5 meters. Hence, a 5 Newton force is acting on this object. We have to calculate the net work done. So first thing we have to do is to do a free body diagram on this object to identify all the forces acting on these objects. So the free body diagram on these objects, we have the normal force going up, and we have the gravitational force going down, and we have the applied force, and we have the friction. So now the displacement goes to the right. So looking at the displacements, the direction of the movements, and the forces, we can see that the angle between the displacements and the gravity or the normal force is 90 degrees. So the normal force and the gravity does no work. They do zero work on the objects. So now our net work done is therefore equal to work done by the applied force plus work done by the friction plus work done by the gravity and plus work done by the normal force. So to calculate work done by the applied force, we take the force in question, multiply by the displacement, and multiply by the cos of theta, plus the friction. We take the friction, multiply by the displacement, and the cos of theta. And for the normal, because they do zero work, we do not need to expand them. We can just write the 0, 0 there. So now we're going to substitute in our applied force. Our applied force is 30 multiply by the displacement, which is 5, and multiply by the angle, which is 20, plus now the friction is 5, and then 5 multiply by the displacement, which is also 5, and multiply by the cos of 180, because friction and the displacement, the angle is 180 degrees. So now therefore, if we have to work out this part, if I put this part into my calculator, I'm going to have it to be 140,9539, and then 39 plus, now this part here gives me minus 25. So therefore my answer is going to be 115, 9538931, and then to 2 decimal place I'm going to have 115,95 joules. So that's going to be the net work done. Alright, I can also calculate the net work done by using the net work done is equal to the net force times the displacement multiplied by the cos theta. Now, if I say the displacement, if I say the F net, we're talking about the horizontal. Now, on this object here, the forces acting on these objects, the normal force and the gravity does no work. So, to calculate the F nets, we consider the force in the horizontal direction. So, the force in the horizontal direction, we have this force, the 30 Newton force. It has two components. One is the force in the x direction, and the other is the force in the vertical or the y direction. So we consider the force in the x direction or in the horizontal direction. So therefore, to calculate that force, we are going to get 30 cos 20. So our net force, our nets, F nets rather. So our F nets is therefore going to be 30 cos 20. That is our F nets. And multiply by the displacement, which is 5. Oh, that is the 30 cos 20 is just the force, the horizontal component of the 30 Newton force. So we need to subtract the opposing force, which is 5. So minus 5. And then now we're going to multiply this by our displacement, which is 5. And then we are going to multiply it by the cos of 0, because the net force goes to the right and the displacement also goes to the right. So if I have to put this inside my calculator, everything, I'm going to get 115, 95, 38931. So to 2 decimal place, I'm going to get 115,95 joules. So to calculate the net force, you can use the F nets times the displacement cos theta, or we can calculate the work done by the individual forces and then add them together. Thank you.